Introduction to Econometrics. So what we are interested in this particular video is to define what is regression, what is a regression line, what is the difference between regression and correlation, what is the difference between regression and causation, and what is these statistical and deterministic variables. So what are those? Now, regression as a term, it was, first of all, it was studied by someone who was called Francis Galton. Francis Galton. So what Francis Galton studied, he said this, that if you take up the height of the father and you take up the height of a child, then you will find this, that short fathers, they tend to have short children, and tall fathers, they tend to have tall children. But on an average, what we see is that the height of children is going to go, or is going to tend towards the average, right? Average of the population. So हम क्या कहना चाहते हैं यहाँ पे? That is basically what we want to say is that supposedly if there is a 6 feet tall father, then his son will be 5 feet 11 or 6 feet 1 or 6 feet 2 or someone. So taller children. Or if there is a short father, 5 feet 4, his sons could be 5 feet 5, 5 feet 6, 5 feet 1, 5 feet 2, something, right? But on an average, if you take up all of these children, all children in the population, and you take up the height and you take up the average of their heights, then the height of these children will tend towards the average height. This is the thing which he found out. So let us write that first. Galton found that although there is a tendency for tall parents to have tall children, and for short parents to have short children, right? The average height of children average height of children born of parents of a given height tended to regress or move towards the average height of the population. Average height of a population. This is what he found out, right? What we are interested in. So what we are saying here is this. Here you have fathers' heights. So there are different fathers in a population. And here you have son's height, right? मान लीजिए, this is one height, x1. This is another height, x2. This is another height, x3. This is another height, x4, and so on. जैसे 5 feet, 5.5, 6, 6.2, something like this. Now, supposedly, if the height of the father is 5 feet, right? Then the height of children will be somewhere here, right? Like this. Could be different children with different heights born to a father whose height is 5 feet. Different children. I mean, in one population, we have taken fathers whose height is 5 feet. And for each of these fathers whose height is 5 feet, we have taken son's height. What are their heights? So they will be in a range, right? They will be in a range. Say, मान लीजिए, from 4.9 to 5.3 somewhere. Similarly here, there are fathers whose height is 5 feet 5. Now, for each of these fathers, we have taken height of sons. So those we have found out would be anywhere between 5.4 to 5.8, somewhere, right? Different. So what we have done is we have fixed the height of the father. And then we have found out, okay, for these heights, what are the different height of the sons? Then again, height of the father is 6 feet. For all those fathers whose height is 6 feet, we have found out what is the height of the sons. And we found out that height of sons could range between 5.10 to 6.1. And all those fathers whose height is 6 feet, again, we have taken the height of sons, which can lie between 6 point or 5, 6. This was 6.2 now. So it will be 6.1, 6.4, something. It can go like this. There are a few things about it. First, what is this scatter diagram telling you? This scatter diagram is telling you the height of sons in a hypothetical population, right? There are the height of sons in a hypothetical population corresponding to the fixed values of the height of father. So you are fixing the height of the father, and then you are finding the height of sons. We haven't regressed anything yet. Okay? So please write the first point. So what is this telling you? This scatter diagram gives the distribution of height of sons in a hypothetical population, corresponding to the given or fixed values of father's heights. Right, beta? Okay. For every given height of the father, there are the range of values for the height of sons. That is the second point, right? To any given height of a father, is a range or distribution of heights of a son, right? Of not of a son, of sons. Then there is there can be the variability in the height of the sons. You can see this. There is a variability. Even for a given height of the father, there is a variability in the height of the sons, right? So if there is a variability in the height of the sons, but what you are also seeing, as the height of the father is increasing, the average value of the height of sons is also increasing. No? Average value of the height of sons is also increasing. So for example, so here you have the given height of the father is 5 feet. Height of sons can range from what? 4.9 to 5.2. Right? So we have the different height of sons for this particular given height of the father. And let's say the average value is this. This is the average value, right, of this distribution. For 5.5 height of the father, there are different height of sons. So, and the average value for this range is this. For this range is this. For this range is this, let's say. Right? Huh? And what you do is that if you, okay, first of all, let's go slow. So what you have is, yes, there is a variability in the height of the sons. But as the height of father is increasing, you can see that the average height is also increasing. No? That's right. So please write it. Despite the variability of the height of sons, right, for a given value of father's height, the average height of the sons the average height of the sons generally increases as the height of father increases. As the height of father increases, right? So first thing is this. And I have marked these average height with these points, right? So this is the average height of the sons for a father whose height is 5 feet. Average height of the son for a father whose height is 5.5 and so on. So you connect these average points, So what is this? And by connecting these points, what you get is called the regression line, right? And this regression line is showing that the average height of sons is increasing as the height of the father is increasing. Average height of the son is increasing. Average height of sons is increasing as the height of the father is increasing. First thing. Now, what is this regression analysis telling you? Don't you think this becomes a dependent variable right? And this becomes the independent variable. No? This becomes the dependent variable and this becomes the independent variable. So what you are trying to say? You want to predict the average value of the independent variable for a given value of the dependent variable. This is what regression analysis is telling, right? Independent variable or explanatory variables, these are same thing, right? So here in our case, what is it that you want to do? So you have sun's height is a function of father's height. No? Sun's height is a function of father's height. This is what it is. So you want to predict the average value of the sun's height for a given value of father's height. You want to predict that. So if you're given, okay, this is father's height. So by the regression analysis, you should be able to find out what is, you can predict that this is going to be the sun's height, right? So should we write one line? So please write this. Regression analysis is concerned with the study of with the study of dependence of variable whose dependence on what? The dependence of the dependent variable on the independent variable. The dependent variable on the independent variable, right? With a view to estimating or predicting एक population mean. अभी मैंने आपको नहीं बताया है ये what is population mean and all. Predicting the mean of the dependent variable so isn't this the thing which you are doing right now here? So are you not predicting the average of the dependent variable for a given value of the independent variable? That's what you're doing. Of the dependent variable in terms of the known or fixed values the fixed values of the independent variable, of the fixed values of the independent variable, right? Acha, now if you just have a look at this, you will find this that what is there are two different kind of variables. One are the statistical variables, others are deterministic variables, right? So what are those statistical and deterministic variables? Let's write that. Statistical variables and deterministic variable. So when you talk about statistical variables, just say the relation which we have just talked about. So we are dealing with the random variables. We are dealing with the stochastic variables, right? So your book also gives you the example of, just say, for example, the example which you have just taken, that is son's height is dependent upon father's height, right? But I mean, note that it is coming from a theory. In general, you see that, okay, this happens. Generally, we find that tall parents will have tall children or short parents will have short children. So this is coming from, it's not deterministic. You can't exactly say, no, no, a 6 feet father will have a 6 feet son. No, this we don't know, right? Deterministic variables are, just say you have the law of physics, right? So those are deterministic variables. So you mix the proportion in a certain way, you will get the outcome as it is, right? So please write. Here we deal with stochastic or deterministic, sorry, stochastic or random variables. stochastic or random variables. So when you say stochastic or random variables, it means that they have a probability distribution. That is, they have a probability distribution, right? So the example in your book is, for example, there is a crop. The output of the crop is dependent upon the rainfall, soil moisture. It is dependent upon various other things. But this relation which you are talking about, that is statistical in nature. You exactly don't know how much rainfall is going to be there. Or you can't even tell that, okay, this amount of rainfall and this amount of soil moisture will produce only this amount of crop. No, no, no. So that is statistical in nature, right? There is bound to be some kind of random variability in the dependent variable, right? So how much crop output is going to be there? You don't know that is random. We don't know. अगर हमारे पास, if we know exactly this is the soil moisture, this is the temperature, and these are the other factors also, then also you can't predict it with exact uh, what do you call probability that yes, this is going to be the crop output. No, 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 no. Right? So, right. So, just say, for example, you take up an example like this. So from now on, okay, I'm not writing it that way, but just think about this way. So income of an individual I is dependent upon education of individual I. It is dependent upon what? Um, Geography. No? Of individual I. It is also dependent upon gender. Individual I. It is also dependent upon experience of individual I. So you can take up many examples or many explanatory variables to determine what is going to be the income of the individual I. So just think about it. If the education of the person is going to, I mean, if he's going to be like highly educated, his income, assuming everything else constant, you will assume that income is going to be more. For the same amount of work you're doing in India, and the same amount of work you're doing in US, you will be getting higher amount in US, higher income in US as compared to India. So geography is good. There are studies and studies which show that male counterparts, they get higher wages, higher income as compared to for the same work for the female counterparts. Experience, if you have more experience, there is going to be higher income for that individual. Now you tell me, if we know what is the education of the person, if we know what is from where he's coming, if we know what is his gender, if we know what is his experience, and we know other things also, can you predict with certainty what is going to be an income of an individual? Okay, you run the model, you will get some value here, but that value may or may not be equal to the actual income. You with me? So that is what the statistical in nature is. Deterministic means here we deal with relations as in classical physics, right? For example, Newton's law of gravity, right? For example, Newton's law of gravity. Huh? So, I mean, you know the things which are going to affect gravity. So if you know that, you will be able to find out what is the relation. So that's a deterministic relation, right? Then there is something which is called regression and causation. Regression and causation. अब जैसे see causation, you understand, that is X is going to cause this effect in Y. That is what causation is. So education of an individual is going to cause higher income for the person. So that's a causation. But just because you are running a regression, it doesn't mean that there is going to be a causation. You with me? So I know that income of the individual is going to be caused by good education, right? But what I don't, I mean, supposedly if I just run the regression, like income of an individual is going to be dependent upon the eye of your color of your eye. I mean, you run the regression, you will be getting some amount, some data or some number, but that doesn't imply causation, no? Just because you're running a regression, it doesn't imply causation. So regression has to come a priori through some kind of theory. It has to come through some common sense. Okay, this is going to affect this. You with me? So regression does not necessarily imply causation, right? Uh, our ideas of causation must come from outside. Must come from outside statistics. Right. I mean to say it should come through the common sense or some kind of economic theory, could be anything. So ultimately, some theory or other, right? So one thing is that. So if you get a question like that, regression implies causation, no, 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 right? And then you have a very simple point between regression and correlation. Regression and correlation. So what are you doing in regression? You are trying to predict the average value of the dependent variable given the fixed value of the independent variable. You understand what are independent, what are dependent now? So I've told you earlier also. So all of these are independent variables. This is a dependent variable. So in our father-son example, son's height is the dependent variable, father's height is the independent variable. So for a given value of the independent variable, you are trying to predict the average value of the dependent variable. This is what you're doing in regression. we try to estimate or predict the average value of one variable on the basis of fixed values of other variables, right? In case of correlation, what you do? In case of correlation, you try to find out the strength or between the two variables, right? Or the degree of linear association between the variables. So you don't say that X is correlated. Of course, you say X is correlated with Y and Y is correlated with X. That means one and the same thing, right? But here you will say Y is dependent upon X. You don't say X is dependent upon Y in case of regression. In case of correlation, that is just a degree or strength of the relationship between the two variables, right? So, say for example, the person getting marks in mathematics test and the person getting marks in science test. So we can say that they are correlated. So both of them are moving in the same direction, right? It measures the strength or degree of linear association between two variables, right? So when you talk about correlation, you are treating both of them equally, symmetrically. It doesn't matter when you are giving more importance to the marks in mathematics test, or you're giving less import or more importance to marks in science test. No, both of them are treated symmetrically. But as far as regression is concerned, you say son's height is dependent upon father's height. So you want to predict the average height of the sons, right? So it means what you are giving. So the relation is asymmetric. You're giving more importance to the dependent variable, right? So asymmetry. Asymmetry. The relation between dependent and independent variables. So dependent variables, they are treated as random. They are treated as stochastic. You know the reason why? Even if you know the exact height of father, you cannot predict with certainty what is going to be the height of son. So there is a randomness involved in the dependent variable, right? Dependent variable is treated as random or stochastic. While independent variables are assumed to be fixed in repeated sampling. So I will talk about this word repeated sampling in detail in other videos because I need to tell something more about it. हाँ? अभी के लिए बस इतना लिख लीजिए that independent variables, they are treated as fixed. जैसे height of fathers is an independent variable, is an explanatory variable that is treated as fixed, right? What about correlation? So here, both variables are treated. Both variables means one is dependent variable, other is independent variables. They are treated symmetrically. In fact, there is no dependent or independent variable in correlation. So there is no distinction between the explanatory variable or the dependent variable. No distinction between dependent variable and explanatory variables. You with me, beta? So I think this is, I guess, chapter 1 of Gujarati. Please read this text very nicely. That's an excellent text. So I think I forgot to write the reference. I think basic econometrics. Basic econometrics, Gujarati. I might have an old edition, but you buy the newest book and make notes side by side. So I've given all the important points. You might want to read the chapter again and then write it. Okay, beta. So I hope this was useful to you. Thank you.